Yeah, hello everybody. Welcome back to our next lecture in digital signal processing. And the last class we have discussed on what is the classification of discrete signals and what is the basic block diagram of a DSP. Just I am revising that the block diagram of DSPs consists of analog to digital converters and a system which is in the discrete manner and then digital to analog converter. So this is the block diagram we have discussed in the last, and you have different types of signals. The signals are which are used, both continuous format will be there and discrete format will be there. In our digital means digital signal processing, we will use discrete signals, and we have studied about the different types of signals and classification of signals in the last class. Now coming to the now, today we have discussing about the classification of discrete systems. Means how the discrete systems are classified and how they are predicted by using that type of output. Means if you see here, classification of discrete systems. Whatever the continuous system have, continuous system, the same systems will be there in the discrete system also, but here the output and input in the form of discrete means ones and zeros, discrete format, where in the discrete system is DSP, digital signal processing, we will use discrete systems. Coming to the classification of discrete time systems, depend upon the type of input and type of output. The discrete time systems are broadly categorized into these many types. So many types of discrete systems are available. In those, we will discuss some of the main discrete time systems. Here if you see, discrete time system means the system which is varying with respect to the time. So static and dynamic time system, and causal and non-causal system, linear and non-linear system, time invariant and time varying systems, stable and unstable systems, invertible and non-invertible systems, FIR and IAR systems. These are the different type of systems broadly categorized. So, what is meant by the static and dynamics? What is meant by these systems? So, whatever the input you are giving, the response will be coming through the system is depend upon the present input. Means the input may be present input or past input or future input also. It can predict. Means y of n also present output and past output and also future output. So depend upon this present, past and past inputs, the systems are classified into these many times. Coming to the static and dynamic system, already you know the general meaning of static means nothing but it can't be changed, means like constant. So here also static means a system which will depends only on the present inputs. Means I have given one as a input to the a system which is in the discrete format, then it will produce the output at the time of one only. Means what the one is there, that will be produced at the output at a time of t equals to 0, and it has to produce at time t equals to 0. Something delay will be there. So means the memoryless system, the static system is also called as what? Memoryless system. The memoryless system, if the output of the system at any instant of n only depends on the input sample. Whatever the input sample is there at that time, then the system is called memoryless or static system. Means that will be depend upon the present input, not on the past input and the future inputs. It will produce the output based upon the present input. Then that type of systems are called static systems or memoryless systems. And coming to the dynamic systems, dynamic means which will can change. In general meaning, I'm saying that here the dynamic system, otherwise the system is said to be dynamic or to have memory. Means what is that? It has memory, so it can store the past inputs and future past outputs, and it can give the present output. Depend upon that, it will give the present input and a past output. If you see here, the dynamic systems which will be depends upon present input as well as the past inputs. So it will give the output depend upon that. If you see here, for example, the for memoryless system or the static system, if you see here, y of n equals to a x of n plus b. Some example here, one equation is given in the form of y of n equals to a into x of n plus b x square of n. So he's saying that it is a static or memoryless system. How? Means suppose I am keeping the present input at the time n equals to 0 interval. So what will happen if you substitute this n here? Y of 0 equals to a into x of 0 plus b into x square of 0. Means if you see here, this equation at time n at time n equals to 0, y of 0 is nothing but what I am generally will take it as y is output and x will be the input. So if you see here, the output at 0 interval depend upon the inputs of at 0 interval only, not on the previous one. So it is said to be a static or memoryless system. Coming to here, y of n, suppose same I am taking n equals to 0. So what happened? Y of 0 equals to x of 0 minus 4 into x of 0 minus 2. That is nothing but y of 0 equals to x of 0 minus 4 into x of minus 2. Means 0 minus 2. So what is this? X of minus 2 is the past input. Means it is shifted before 2 samples and it is 0 input. Means present input. This is also present. But here the present input is 0, but it is depends upon the past values. So it is called as a dynamic system. Okay. So coming to the dynamic system, if you see here x of n minus 4 into x of n minus 2, it is nothing but what? It's type of difference. Difference will be there in the input samples. Nothing but this type of equations we will call as difference equations. What equations? Difference equations. And you can say that every dynamic system has a difference equation. Nothing but every difference equation is said to be a dynamic system equation. Okay. Coming to the next. Here we will see the different examples for the given system. So here given, what is given? Y of n equals to x of n plus 2. Here answers also will be available. So we will see how we will tally the system is dynamic or whether a static. Coming to here, suppose I am keeping n equals to 0. Why I have to keep? Means you can keep any value, positive value or negative value or neutral 0 you can keep. After keeping you will get what is the system behavior will be. According to the system behavior you can classify that system either static or dynamic or any other system. If you see n equal to 0, what will happen if you keep n equals to 0? Y of 0 equals to x of 0 plus 2. That is nothing but y of 0 equals to x of 2. Means what? Y of 0 is the present output, means at time interval 0. If you coming here, this is what? Future value. Yes or no? X of 2. I will be there in the 0 sample at the stem of 0, but it is going at the stem of 2. It need, for getting y of 0, it needs a sample 2 of input. So it is depend upon the future values. That's why it is called what? Dynamic system. That's why the first one will be called as dynamic system. Okay. If you coming to the next example, see here. Y of n equals to x square of n. So we will see. I am keeping n equals to 0 now. Y of 0 equals to x of 0 means present and present. So present means present. So present will be equals to present means it is static. If you have any doubt, you can keep n equals to minus 1. So what happened? Y of minus 1 equal to x square of minus 1. This is also present. This is also present. Yes or no? So this is present and this is present. So this will be called as static system. Okay. We'll see another example here. Already I said that earlier. Every dynamic system has a difference equation. Means it is in the form of difference. So it is a dynamic default, but we will check whether it is dynamic or not. We will see. Suppose I am taking n equals to 0 in the above equation. What will happen? Y of 0 equals to x of 0 minus 2 plus x of 0. Nothing but x of minus 2 plus x of 0. That is equals to y of 0. This is the equation here. So y of 0 is the present input, and this is the past, and this is the present. So it will depends upon what? Past outputs also. Then it is obviously dynamic system. So okay, every time you are keeping n equals to 0 and you are saying that the system is dynamic or static. So that's why just I am going through that. Now I am keeping n equals to -10. Okay, we'll see what will happen. So y of -10 equals to x of -10 minus 2 plus x of -10. So -10 is the what? Present output. This is the present output. Coming to here, x of -12 plus x of -10. If you coming here, x of -12 is not nothing but what? Past input. Your at which sample you have? -10, but you are getting at a past input -12 before two samples, and here also here is present only, so nothing, it's no happen. So past input and present input is depending upon the present output. Means what is that system? Dynamic system. Already we know that static will be depends upon present inputs, not on the future and past inputs. Dynamic is nothing but what? Past inputs maybe, and present inputs maybe, and also future inputs also. That is the difference between static and dynamic. Here, why static system is called memoryless system, why dynamic system is called memory system. So coming to the static system, here it is depend upon only what? Present values. So whatever the input you are giving, that response will be coming. So no need of getting the memory, no need of storing those. Whatever the input is giving, the output will be coming. So coming to the what dynamic system, the dynamic system is having what? Past and future values also. So it has to store the values to get the output. So that's why dynamic system is called memory system, because it uses a memory to get the output. Okay, someday. Next we will go to the causal versus non-causal system. Causal versus non-causal systems. It is also like a system. Is in causal system, the output at any time n depends on the present and past inputs. What? Depends upon the present and past inputs, not on the future inputs. Be carefully listen here. Causal system is what? It will depends on present and past, only present and past. Then the system is causal system. All other systems are non-causal. So coming to the non-causal, a subset system is will be also there. A system where the system output anytime any only depends on the future inputs is called anti-causal. Means in non-causal means what? Depends upon present, past and future, but only the system will be depends on future inputs. That type of systems are also called as anti-causal systems. Anti-causal systems. So here what? Anti-causal system is a subset for the what? Causal, non-causal system. Okay. So these are the difference between causal and non-causal. Coming to the examples. If you see here, like as in the stable and static and dynamic systems. If you coming here, here the given equation, first one, y of n equals to x of n plus x of n minus 2 is given. So I am taking n equals to some 10. This is what? Present input. So y of 10 equals to x of 10 plus x of 10 minus 2. What is the value? X of 10 plus x of 8. Y of 10 equals to how much? What you get? Y of 10 equals to x of 10 plus x of 8. This is present input, and this is what? Past input. Sorry, present only 10 na? Present input, and this is what? Past input. Means the system output is depend upon the present input and also past input. What is the type of system? Nothing but a causal system. I have already told causal depends on present and past inputs. Anti-causal future. non-causal both the values. So coming to the next system, if n equals to y of 0 equals to x of 0 and y of 10 equals to x of 10, means it will be depend upon the present only. So it is also like a causal. So coming to the non-causal, if you see here, I am substituting here y of 0 equals to x of 0 plus n into 0 into something 0, and if it is n equals to 1, x of 1 plus 1 into x of 1 minus 1 is 0. Okay, so this is also what type of system? This is n equals to 1 means present, this is past. So till now it is a causal only. Next we will see n equals to 10. Suppose what will happen? Y of 10 equals to x of 10 plus 10 into x of 9. So this is present, past, and present, past. So this is also a causal system. So we will go through the negative values now. We'll see what will happen here. Some systems will think like it is a causal or a non-causal, but the thing here is sometimes we'll check for the negative values and positive values and zero values also, because you can't predict it is which system it is. So that's why anytime you have to keep n equals to neutral value and also a positive value and negative value. So n equals to minus 10 I am keeping here. What will happen? Y of minus 10 equals to x of minus 10 plus n into x of minus 10 minus 1. That is x of minus 10 plus n into x of minus 11. So what is the system? Non-causal. Simply you can say that. Yes or no? So this is the thing. So coming to the stable versus unstable system. Stable system is nothing but which will be having bounded input for the bounded output. You know that already, that the before condition, for the finite input the output should be finite. So it will be lies between the infinity. So it is a one type of stable system and it is also a one type of unstable system. We'll see the example for this also. And coming to the linear versus and non-linear systems, every linear system and every linear system has to obey the superposition principle. What is superposition principle? The weighted sum of two inputs together will be equals to the individual weighted sum of those inputs. Means t of a x1 of n plus b x2 of n equals to a into t x1 of n plus b into t x2 of n. A relaxed linear system with a zero input. See here, I am taking a system with x of n input and y of n is the output. If then what will happen? I am multiplying with a constant k x of n, that it has to produce the same output like as a y of n with the coefficient of k. Scaling property, nothing but. So if coming to the here, x1 of n I am giving, y1 of n is giving, x2 of n I am giving, y2 of n it is giving. Now I am combining those two inputs and then it has to give those combination of those two inputs. This is nothing but a additive property. So linear versus non-linear means it has to satisfy the superposition principle, and superposition principle is nothing but the weighted sum of the two inputs will be equal to the individual sums. Okay. And these are the examples. If you see here, example is y of n equals to x of n square, So I am taking y1 of n for the first, I am taking the first discrete time system, and that is y1 of n equals to x1 of n square and y2 of n equals to x2 n square. So coming to the y3 of n means combination of those two will be equal to a1 x1 of n square plus a2 x2 of n square. So a1 y1 of n plus a2 y2 of n equals to also a1, means it is a linear system. Okay. These are some examples. If you see y of n equals to x of 2n, so what will happen? We'll see. Now I am taking y1 of n, though it will be the x1 of 2n. Now I am taking y2 of n, that will be nothing but x2 of 2n. So now I am taking that whatever what he has taken y3 of n equal summation of these two. So I am also taking like that t of a1 x1 of n plus a2 x2 of n. What will happen here? a1 x1 of 2 y1 y1 of n y2 of n. So what will happen? A1 x1 of 2n plus a2 x2 of 2n. You can take here either y or x. So coming to the individual terms, what will happen? a1 t x1 y1 of n plus a2 t y2 of n. So what will the value? a1 y1 of n is x1 of n plus a2 x2 of 2n. So if you see these two are same. This system is linear system. If you come here, cos xn, so it is simply you can say that it is a non-linear system because it is a cos. So time variant and time variant systems. In the name only it is there. Time invariant means it will change with respect to time or not. Invariant means it won't change with respect to the time. What is time variant? With respect to time, it will vary the system output. The type of systems are time invariant systems. So here time invariant example is nothing but a differentiator. Here x of at the time of x of n after time interval t, it is giving y of n equals to x of n minus x of n minus 1. Means it is changing with respect to time or not? No, because the sample is changing. So if you come here, it is changing with respect to time. Means it is multiplying with a cos of omega naught n. It is changing with respect to time, so it's a time variant system. These are the different examples for the time invariance. By seeing this, you can say that n minus 1, this is a time invariant system, means it is shifting towards the, and x of n by 2, it will come to the below level, then it is a time variant, and it is also a time invariant system. Thank you. So these are the things, classifications of the discrete time systems. In the next class, we will see how the conversion of continuous time signals into the discrete time signals. It is nothing but by using sampling, we will convert the continuous time signals into the discrete time signals. We'll see in the next class that one. Okay, thank you.